What you're about to hear would have sounded like science fiction 2 years ago. A developer ran a 400 billion parameter AI model, the kind of model that typically demands racks of expensive GPU servers on a consumer MacBook laptop with 48 gigabytes of RAM, not streamed from the cloud, not borrowed from a data center, running locally on a machine you could carry in a backpack. The developer combined 3 key ingredients: Claude Code as the orchestration layer, Karpathy's autoresearch repository, and Apple's research paper called LLM in a flash. Together, these enabled Qwen 3.5, a 397 billion parameter model, to run locally. The result was roughly 1 token per second using 21 gigabytes of RAM, with the remaining model weight streaming directly off the SSD. It wasn't fast, but it worked. The real innovation buried in this story is Apple's LLM in a flash research. Traditionally, a model must fit entirely inside RAM to run. Flash inference breaks that constraint by streaming model weights from SSD storage on demand, only loading the pieces needed for each inference step. Yes, there's a speed penalty, but the capability unlock is profound. Suddenly, models 10 times too large for your RAM become runnable. This is a fundamental architectural shift in how we think about local AI deployment. For years, the AI industry operated on an unspoken axiom. Larger models require more compute requires data centers, therefore frontier AI belongs in the cloud. This logic shaped product decisions, business models, and developer workflows across the entire industry. But the combination of more efficient models, better quantization techniques, and hardware like Apple Silicon with unified memory is eroding that axiom faster than most people realize. The 400 billion parameter local run is an extreme proof point, but the trend is unmistakable. 1 token per second feels agonizing if you're waiting for a chat response. But reframe the use case and the math changes completely. Running a research agent overnight that synthesizes hundreds of documents? Viable. Processing a large codebase for refactoring suggestions while you sleep? Viable. Batch analyzing datasets without API rate limits interrupting at 2 in the morning? Completely viable right now. The bottleneck is interactive speed, not capability. And optimization work on flash inference is still in its early stages. These numbers will improve significantly. Running a 400 billion parameter model locally isn't just a technical achievement, it's a business model shift. Zero API costs means the economics of heavy AI usage flip entirely. No data leaving your machine means sensitive code, proprietary research, and private documents never touch an external server. No rate limits means your workflow runs at your pace, not a vendor's throttle. These 3 advantages compound. Developers and organizations who build workflows around local inference gain a structural cost and privacy advantage that compounds over time. The 48 gigabyte unified memory MacBook was considered a prosumer luxury purchase a year ago. Today, it's a legitimate inference node for frontier-class AI models. Apple Silicon's unified memory architecture, which shares RAM between CPU and GPU, turns out to be architecturally well-suited for the kind of weight streaming that flash inference requires. This wasn't an accident. Apple's internal AI research team clearly had local inference in mind. As the M-series chips continue improving and RAM capacities expand, the gap between a developer's laptop and a cloud GPU cluster will keep narrowing. Cloud inference is not going away. It will remain essential for real-time applications, massive scale deployments, and teams without specialized hardware. But the ceiling on what you can accomplish without cloud infrastructure just moved dramatically higher. The developers and organizations who invest now in building workflows around local inference, even slow local inference, will accumulate compounding advantages in cost structure, data privacy, and operational independence. We are in the early innings of a shift that will look obvious in retrospect. The question is whether you're building for that world today.